Alright, welcome everyone. Today we're going to look at TSI Prep Intermediate Algebra Day 1. Our first section here, we're going to be solving equations. So, number 1, 2x over 5 is equal to negative 3.8. The first thing that I would like to do is, since I see this 5 here, I'm going to multiply this left-hand side by 5. And I'm going to multiply the right-hand side by 5 as well. And the reason why I'm multiplying both sides by 5 is so that I can get rid of this 5 in the denominator. So the 5's will cancel, and on the left-hand side, I'm going to be left with 2x, which is equal to negative 3.8 times 5, which is negative 19. So now I can go ahead and divide both sides by 2 here, and you're going to be left with x equals negative 19 over 2. So if I divide this, I'm going to get a decimal, but negative 19 over 2, that fraction is already simplified, so I can just leave my answer like this, x equals negative 19 over 2. Number 2, 5y minus 5 over 3 equals 6y plus 3 over 6. Now, this is where I have a proportion where two ratios are equal to each other. If I have something like this, I can go ahead and cross multiply. So I can multiply these two things, equal that to these two things multiplied. So I have 3 times the quantity of 6y plus 3 equals 6 times the quantity of 5y minus 5. So then I can go ahead and apply the distributive property. So for the left-hand side over here, I have 18y plus 9 equals 30y minus 30. So then I can go ahead and subtract both sides by 18y, and then I will get 9 equals 12y minus 30. And I'm going to go ahead and add both sides by 30 here so I can get 12y by itself. So I have 39 equals 12y. And so if I divide both sides by 12 here, I get y equals 39 over 12. And I'm going to look at this answer that I have here. Can I simplify this? Well, I know that 3 goes into 39 and 12 at the same time. So let's divide the top and the bottom by 3. And I get 13 over 4. So y is equal to 13 over 4. All right. So number 3, we have 2 over x minus 3 over 4, which is equal to 2 over 2x. Now, before we solve this equation here, first off, we notice that there are multiple fractions involved. Before we solve this equation, what I like to do is, since I notice that we have an x here on the left-hand side of the equal sign and a 2x here on the right-hand side of the equal sign, I want to make sure that these x's are on the same side of the equal sign so that they have, like terms that we can work with on one side. And then this 3 over 4, they are not like any of these other terms here, so we're going to move that to the other side of the equal sign. So we're going to subtract both sides by 2 over 2x. And we're going to move this 3 over 4 to the other side. So we're going to add both sides by 3 over 4. So what you should have now is 2 over x minus 2 over 2x equals, so we're adding both sides by 3 over 4 here, right? So these will cancel, and then we have this 3 over 4 to the other side of the equal sign. So this is what I'm saying. We have the x's on the left-hand side of the equal sign, and then we have this 3 over 4, which doesn't have anything else that are like this, okay? So now what we can do is we can change this, because in order for us to subtract these things, right? Subtract these fractions, we have to have the common denominators involved. So we have an x here, we have a 2x here. In order for them to be the same, this needs to be multiplied by 2. And whatever I do down below, I have to do up top as well. Okay? So now this becomes 4. So 2 times 2 is 4. 2 times x is 2x. Minus 2 over 2x equals 3 over 4. Okay, so look, we have common denominators now. I can go ahead and subtract these two fractions. So 4 minus 2, that's 2 over 2x equals 3 over 4. I can simplify this, but it doesn't really matter because now we have these two ratios that are equal to each other. I'm going to cross multiply just like I did with number 2. So I will cross multiply the 2x and the 3. So that's going to be 6x equals the 2 and the 4. 2 times 4. So that's 8. Now, I'm going to divide both sides by 6 here. So x is equal to 8 over 6. Or if I divide the top and the bottom by 2, I have 4/3. That's going to be my simplified answer. So x is equal to 4 over 3. Number 4, just like what we did for number 3, the best thing about number 4 here is that we do have like variables here. So we have a 2h and an h, and then we have this h minus 1 on the other side, okay? So we don't need to move anything else. All we have to do is for the left-hand side of this equal sign here, we need to have common denominators. We have a 2h and we have an h. So I need to multiply this bottom part of the fraction here by 2. And I need to multiply this top part of that same fraction by 2 as well. So that's going to remain the same, but I have 5 times 2, that's 10, and then h times 2, that's 2h, equals 3 over h minus 1. And I can go ahead and add these fractions here. So 1 plus 10, that's 11, and then you keep the denominators. Okay? So 11 over 2h equals 3 over h minus 1. We will cross multiply, so 3 times 2h, that's 6h, equals, then the 11 times the quantity of h minus 1. So 11 times the quantity of h minus 1. I can distribute the 11 to each term here, so 6h is equal to 11h minus 11. And then I can solve. So subtract both sides by 11 here, or 11h. And then you're going to get negative 5h on the left-hand side of the equal sign equals negative 11. I will divide both sides by negative 5. So h is equal to, so I have negative 11 over negative 5. You know for sure that the negatives will cancel. So you're left with 11 over 5. And I don't need to simplify this at all. So this is your answer. All right, now we're going to go ahead and move on to solving inequalities here. Number 5, negative 8w plus 4 is less than or equal to 12. So this is essentially solving equations, but we're dealing with inequalities here. We're going to go ahead and make sure that the variable is on the left-hand side of the inequality, and then the number is to the right. So let's subtract both sides by 4 here. I have negative 8w is less than or equal to 12 minus 4, that's 8. And now I'm going to go ahead and divide both sides by -8 here to get w by itself. So then I have w, and then since I'm dividing by a negative here, since we're dividing by a negative, we flip the sign. So now this less than or equal to becomes greater than or equal to. So 8 divided by -8, that is -1. And if we were to draw a graph or a number line, here's -1. And since this is greater than or equal to, that means it's included. And we are going to shade to the right here, because all the numbers here are greater than or equal to -1. For 6, we have 3x minus 9 over 6, which is greater than 40. Let's get rid of the 6 in the denominator here. So that means we're going to multiply this whole thing by 6. So I'm going to multiply the left-hand side by 6, and I'm going to multiply the right-hand side by 6. So the 6's will cancel. So I have 3x minus 9, which is greater than 40 times 6. That is 240. I'm going to go ahead and add both sides by 9 here. So 3x is greater than 249. Let's divide both sides by 3 here. So x is greater than 249 divided by 3. That's going to be 89. So your answer is x is greater than 89. Let's draw a graph. Here's 89. That's our main character. Since this is just a greater than sign, not an equal, that means that this is not included. It's going to be an open circle. So then, where do we shade? Do we shade left or right? Well, all the numbers are greater than 89, so it looks like all of your answers will be to the right. Okay? Alrighty. Number 7. A recipe for 2 dozen corn muffins calls for 3 cups of flour. The number of muffins varies directly with the amount of flour. How many cups of flour are needed to make 6 dozen muffins? So that means when we see these words here varies directly, we're going to create something called a proportion. So basically, what we did here. So, a recipe for 2 dozen corn muffins calls for 3 cups of flour. So our ratio is going to look like this. We're going to go from muffins to flour. Okay, so muffins will be up top, flour will be down below. So for this batch, we have a 2 to 3 ratio. So 2 dozen corn muffins, again, that's going to be up top, over 3 cups of flour. That's going to be down below, just like what we have over here, which is equal to this batch here. How many cups of flour are needed to make 6 dozen muffins? So this right here, we don't even know how many cups of flour we need to make 6, right? So this is going to be our x. That's our unknown, right? So again, we're going from muffins to flour. So the ratio needs to follow suit with what we have over here. So we have 6 dozen muffins. So that means 6 is going to go up top. And that's going to be over our unknown x cups of flour. That's going to be x here in the denominator. Now, we have our proportion ready. We're going to cross multiply 6 times 3. That's 18. And then 2 times x, that's 2x. Divide both sides by 2 here. So x is equal to 9. So essentially, we have 9 cups of flour needed to make 6 dozen muffins. Cool. So now we're going to go ahead and move on to part 3, which deals with linear functions. We have these 2 types of equations here. We talked about slope-intercept form in the past as well as point-slope form. Slope-intercept form is y equals mx plus b, where you do have the slope, which is m, and our y-intercept, which is b. And then with point-slope form, that's y minus y1 equals m times the quantity of x minus x1. So essentially, you really need a point. You need a point, which is in the form x sub 1, comma, y sub 1. And our slope, of course, that's going to be represented as m. And then you're going to take that and convert that into slope-intercept form. Okay, so let's take a look at number 8 here. Write a linear equation that is parallel to y equals negative 4x minus 3 and passes through 2, comma 4. So since it's parallel, we're going to be dealing with same slope. Same slope. So I'm looking at y equals negative 4x minus 3. Okay? There must be another equation that is parallel to this slope that we have from our problem. So if the original slope is negative 4, right? Our m for our original is negative 4, then our parallel slope, since it has to be the same, is also negative 4. Okay? So now what I can do is I can work with this slope and point. We have our point here, so we have a point and a slope. I can use that point-slope form. Okay, so y minus y1 equals m times the quantity of x minus x1. We're going to label this x1, and we're going to label that y1. So I'm going to write this formula out again. And then I'm going to start plugging things in. So it's y minus y1, which is 4, equals our m, which is negative 4, times the quantity of x minus 2, which is our x1. We're going to go ahead and distribute the negative 4 to each term. So negative 4 times x is negative 4x, and negative 4 times negative 2, that's going to be positive 8. So now I'm going to add both sides by 4 here to get y by itself. This is our goal, to get it to, become y equals mx plus b. So y equals negative 4x. Positive 8 plus 4, that's plus 12. That's our answer. Y equals negative 4x plus 12. Okay. Number 9, write a linear equation that is perpendicular to y equals negative 2x minus 3, and it passes through the point 2, comma 1. So whenever I see the word perpendicular, that means opposite sign, flip your fraction. So this here is our original equation, and it has the slope of negative 2. But our perpendicular slope, what we need to do is we need to change the sign, and since this is negative, our new slope is going to become positive. And this negative 2, by the way, is essentially the same thing as a negative 2 over 1. So our perpendicular slope, we just have to flip the fraction now. So this becomes 1 over 2. Okay? So we have our point, and we have our slope. This is x1, this is y1, and we're going to go ahead and apply that point-slope formula again, right? So y minus y1 equals m times the quantity of x minus x1. So y minus 1 equals positive 1/2 times the quantity of x minus, so our x1 is 2, right? All right, so we're going to distribute the 1/2 to each term. But on the left-hand side, we're going to keep that as y minus 1 for now, which is equal to 1/2 times x. So that's 1/2 x. And then I have 1/2 times negative 2. Essentially, that's just the same way of saying what's a half of negative 2. Well, a half of negative 2 is negative 1 or minus 1. And then I can go ahead and solve for y here. So y equals 1/2 x. And then the negative 1 and the positive 1 will go away. They cancel each other out. So you're left with y equals 1/2 x. That's your answer. 2. All right, so our next section here, systems of linear equations and inequalities. We're going to solve for the point of intersection. So your answer should be in the form x comma y when it comes to these types of problems here. Or for systems of linear equations, that is. For number 10, we have a at x plus 14y equals 4, and negative 6x minus 7y is equal to negative 10. Now, there are 3 ways to solve systems. 1, elimination, 2, substitution, or 3 by graphing. With this one, if I look very, very closely, I can use the elimination method because I notice the 14y, the positive 14y, by the way, and the negative 7y. First of all, the signs will cancel, but if I multiply everything here by 2, if I multiply this equation by 2 and distribute to each term here, right, then I'm going to have negative 14y, and they will cancel. So let's go ahead and distribute to each term here. But first of all, let me rewrite that first equation. So 8x plus 14y equals 4. And then I can go ahead and distribute to each term here. So 2 times negative 6x, that's negative 12x. 2 times negative 7y, that's negative 14y or minus 14y, which is equal to 2 times negative 10, which is negative 20. And remember, we're going to solve this by elimination. So we're going to eliminate both of these numbers here. We have positive 14y and negative 14y. They're going to cancel. And now we're going to go ahead and add down. So 8 plus negative 12, or sorry, 8x plus negative 12x, that's negative 4x, which is equal to 4 plus negative 20, that is negative 16. So now I can go ahead and divide both sides by negative 4 here, and then I'm left with x equals 4, right? So our answer is 4 comma this y value that I need to figure out, right? So let's go ahead and figure this out. What should I do here? I'm going to choose one of my equations from the system. I'm going to choose this first one here, so that 8x plus 14y equals 4. Notice, y'all, that we already found the x value, which is 4. I can replace this x with 4 and then get y by itself, if that makes sense. So I'm going to do 8 times, replace this x with that 4, plus 14y equals 4. 8 times 4, that's 32, plus 14y equals 4. Solve for this 14y here. We're going to get 14y by itself. And I'm left with 14y equals 4 minus 32, which is negative 28. So therefore, if I divide both sides by 14, then that means that y is equal to negative 2. Okay? So our answer is 4 comma negative 2. All right, number 11, we have y equals negative 3x plus 5, and 5x minus 4y equals negative 3. Now, remember our 3 ways of solving systems. 1 elimination, which we did for number 10, 2 substitution, and 3 by graphing. For number 11, I'm going to use substitution to solve for this system here. And the reason being is because if we look very, very closely, I have y equals, and this also applies to x equals 2. But in this case, I have y equals negative 3x plus 5. What I can do here is I can take this and replace this y with this expression. So what I have, if I replace this y with that, I have 5x minus 4, and then since we're replacing this y, let's go ahead and put parentheses around what we're going to put right here, which in this case is negative 3x plus 5, which is equal to negative 3. And now I can go ahead and distribute the negative 4 to each term. So 5x and negative 4 times negative 3, that's positive, what, 12x. Don't forget the x there. And then now we have this negative 4 times positive 5, which is negative 20 or minus 20, which is equal to negative 3. Notice that we can combine the like terms here. So 5x plus 12x, that's 17x, minus 20 equals negative 3. Add both sides by 20. So 17x is equal to negative 17, right? So then, you know for sure if I divide both sides by 17 here, x is equal to 1. X is equal to 1. Now, remember, we need to make sure that our answer is in the form x comma y. We only have the x value. We need to find the y value. But since x is 1, and this equation here is already set up for me to find the value of y, it's already y equals, right? So I can go ahead and take this and replace x with that number. So y is equal to negative 3, and then I'm going to substitute that x, which is 1, plus 5. So y equals negative 3 plus 5. Let's make this look nicer. Negative 3 plus 5, that is positive 2. So we have x equals 1, y equals 2. So your answer should be in the form 1 comma 2. Okay. All right, number 12, y is equal to 4x plus 3, and y is equal to negative x minus 2. And look at that, we have a graph here that we can work with. So we have elimination done, substitution done, and now we're going to solve this system by graphing. Now you're going to have to remember some rules here. You got to remember that these two things are in slope-intercept form. They're both in the form y equals mx plus b, right? The next thing that you have to do is you have to identify the slope-intercept. And the positive 3 and the negative 2 are your slope-intercepts. And then here, the number that is, right next to the variable x or whatever, we have positive 4, and then that invisible 1 here, now it becomes negative 1. Those two things are your slopes, right? So, if I look at y equals 4x plus 3, our first equation, you can tell me that the slope is 4 and the y-intercept, which we represent as b, is 3. Okay? So if I use this graph here, you're going to find the y-intercept of 3, which is right here. Right? Hopefully you can see that. Right? Here's 3. And then you look at this slope, which is 4. that is going to become, 4 over 1. So that means you're going to rise 4. Yes, you're going to rise 4, and then you're going to run 1. So you're going to go up 4 and to the right 1. So we go 1, 2, 3, 4, up 4, and then to the right 1. 1, 2, 3, 4. That's my up 4. Don't mark anything yet. So go up 4, and there you go, right 1. Now, going back to that y-intercept, you're going to do the opposite. You're going to go down 4, left 1, down 4. Oops, I didn't mean to put a dot there. You're going to go down 4, left 1, down 4, left 1, and look at that. You have your line for that first equation there. And this is not going to be perfect, but this is what we have right now for our first equation. And then for our second equation, we have y equals negative 1x minus 2. The slope is negative 1, and the y-intercept is at 2 or negative 2. It's actually negative 2, okay? So maybe I should use a different color, or I think you can differentiate this. But our y-intercept for the second equation is negative 2, so I'm going to go ahead and put a dot right there, or put a point there. And look, we have a slope of negative 1. So if I have a slope of negative 1, that is the same thing as negative 1 over 1. So we have negative 1 over 1. Instead of rising 1, we're going to go down 1. So this here is down 1 because that negative is in the numerator. And then we're going to be running 1 always to the right. Okay, so we're going to go down 1, then left 1, down 1, then left 1, and so on and so forth. Now, this is my y-intercept. We're going to do the opposite. We're going to go up 1, left 1. So I'm going to go ahead and put a point there. And I'm going to circle this because it seems like we have an intersection here. We had a point here for this equation, and while I'm drawing this line here, I also put a dot on that same location there, okay? And then go up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1, and so on and so forth. And look at that. This point here that I circled is negative 1, comma, negative 1. That's the answer to this system of equations. All right, number 13, we have y is greater than or equal to negative 5x plus 4, and y is less than negative x minus 4. Now, this one's a little different because we're going to be dealing with systems of linear inequalities, right? We have the same ideas with systems of linear equations. We just need to know the y-intercept and the slope, and we need to remember how we're going to create our lines. Is it going to be dash? Is it going to be solid? Where do I shade? Do I shade above or below? So all those types of things that you need to remember in order to solve this problem here. So again, we have y is greater than or equal to negative 5x plus 4, and y is less than negative x minus 4. Let's take a look at this first equation here, or sorry, first inequality here. We know that the y-intercept is 4. So if I look at our graph, 4 is located right here. That's going to be our b, our y-intercept. And then this negative 5 is our slope. So that means I need to go down 5, right 1 each time. So I'm going to go down 5, right 1, down 5, right 1, down 5, right 1. And then I need to do the opposite. So go back to the y-intercept, and you're going to go up 5, left 1. Okay? Oh, I made a mistake right here. So that should be... There you go. I'm just trying to make sure that you're going up 5. It's really, really hard to see with this graph. So 2, 4, 5. Okay, there you go. Okay, it looks like that. And since this is greater than or equal to, whenever you have that or equal to involved, that means that your graph is going to be a solid line. Okay? So this is going to be solid. And since this is a greater than, that means we're going to be shading above. So where does above look like? It looks like we're going to be shading right here. Okay? All right, so let's take a look at this other inequality. Y is less than negative x minus 4. All right, so minus 4, negative 4, that is going to be our y-intercept. So I can go ahead and find that on our graph, which is right here. And then negative x, negative 1 is our slope for this inequality. So that means we're going to go down 1, right 1. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, and so on and so forth. Okay? And we're going to go ahead and do the opposite. So go back to the y-intercept, and you're going to go up 1, left 1. Just like so, okay? Now, since this less than sign is, there's no equal to involved, that means it's a dashed line, and we're going to be shading below. So all of these things here will be dashed. Okay? And we're going to be shading below that line. Okay? And I know it's really, really hard to see, but where do they overlap? They overlap right here. This is what you need to circle to show where they all overlap. Okay, so that's 13. All right, so we're going to look at the domain and range now. So number 14, we're going to state the domain and range. Now, before we talk about this stuff, or before we look into number 14, I want to go ahead and remind you what domain and range are. So domain is the set of all x values. The range is the set of y values of all y values. And then a function is where you have x values that do not repeat. Okay, so looking at number 14, we're going to go ahead and find the domain for this function here. And when we look at the domain, we always read from left to right. Okay, so it goes from -3, and then it ends at 1. And these are my x values here. But if we look very, very closely, this is an open dot, and this is a closed dot. So those are important to know as we write our domain. So we're reading from left to right. We start at -3, and we end at 1. And what I'm going to put right here is an x because we're dealing with x values, right? It's the set of all x values. So at -3, we have an open circle. So that means we're going to put a less than sign here, not a less than or equal to sign. But for this closed circle, we are going to put a less than or equal than sign between the x and the 1. So our domain is -3 is less than x, which is less than or equal to 1. Or we can write this as open parentheses, or regular parentheses, -3, comma, 1 with a square bracket right next to it. Okay? So those are two ways to write your answer for the domain of number 14. Okay? All right. The range. The range we're going to read from bottom to top. So we start off with -4, and it goes all the way up to 0. So I'm going to write -4 and 0. Okay? So here we have a closed circle, but if we go all the way up to this 0 here, y'all, we don't even need to worry about this when we're reading from bottom to top. We're looking at the 0, and that 0 is part of the function. It's part of this solid line, right? So in fact, this needs to be closed. Okay? So we have -4 and 0, and we're dealing with y values. So we're going to put y for our variable. And what we need to put between the -4 and the y is that less than or equal to sign. And then same thing for y and the 0 here. Because this is included, that means we need to understand that that is a closed dot. So we need to put a less than or equal to sign between the y and the 0. And you can represent this as square bracket -4, comma, 0 with a square bracket right next to it. So that is how you deal with the domain and range for number 14. For number 15, we have a set of points. We have 2, 3, -3, -2, 4, 5, -5, -4, and 6, 7. So what we're going to do is we're going to determine which ones are x's and which ones are our y values. So all of these things here are the x values, and all the things here are our y's. So then what we're going to do is we are going to put our x values in this thing here and our y values in this thing here. And we don't need to repeat our x values and our y values, okay? So let's go ahead and write our x's. So what I like to do is, why not? We're going to go ahead and have it from least to greatest, if that makes sense. So -5 is going to be our first x value. Our next one is going to be -3. Our next thing here is going to be 2, then 4, then 6. Okay, so I have all my x values from least to greatest. We're going to do the same thing for our y values. So -4, -2, +3, +5, and +7. Okay? So we have -5, and it gets mapped with the -4, right? That's going to be our 1 point. That's -5, comma, -4. Is -5 part of anything else? No. -3, comma, -2. Let's see. Okay, so -3 is mapped with -2. So these two numbers create that point, x comma y. 2 comma 3 Is 2 with anything else? So 2 is only with 3. Is 2 with anything else? There's no 2, there's no 2, there's no 2, there's no 2. Okay, so 2 is mapped with 3. 4, is it with 5? Just 5. Let's see, 4 comma 5, yes. Is 4 with anything else? There's no 4, there's no 4, there's no 4, there's no 4. So it's going to be mapped with 5. 6. 6 is with 7, but is 6 with anything else? There's no x value of 6 here, 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 there. Doesn't matter. So it looks like this is indeed a function. Is this mapping a function? Yes. Why? X values don't repeat. But, y'all, if we said that, if we included that -5 is with -2, right? If this was part of our question here, then it would, this -5 would be mapped with this -2, as well it being mapped with -4 here. So that means that -5 is with -4, -5 is with this -2. It will not be a function if that's the case. Okay, so just keep in mind if that occurs to you at all. All right, 16. Find the range for f of x is equal to -6x minus 9 when the domain is -3, -1, 1, and 2. So all of these things here are the x values. Our goal here is determine the range. Okay, so the range for f of x is equal to -6x minus 9. Now recall from Algebra 1 that f of x is the same thing as y, right? So y is equal to -6x minus 9. All I need to do is replace x with each of these numbers in our domain, right? Once I input the x values, it's going to spit out the y values, which will be part of our range, okay? So let's go ahead and start plugging things in. So if I'm using this, I'm going to use f of x instead of y, but you need to know that f of x is the same thing as y. So if I plug in -3, and it looks like this, right? Then what I'm going to get is -6 times -3, which is positive 18, minus 9. So then 18 minus 9, that's 9. This is our y value, right? That's going to be our first y. So we're going to go ahead and put range, and then we're going to put these brackets here. Our first one is going to be 9. And then if we take this and plug it into this function, just the same process as the other one. So f of -1 is equal to -6 times -1 minus 9. So -6 times -1, that's positive 6 minus 9. So 6 minus 9, that's -3. Okay, so -3 is going to be part of our range. And then lastly, second to lastly, we have the x value of 1. So f of 1 is equal to -6 times 1 minus 9. So -6 times 1 is -6 minus 9. Okay, so -6 minus 9, that's going to be -15. And then there you go. Our last one, f of 2 is equal to -6 times 2 minus 9. Right, so -6 times 2, that's -12 minus 9. That is -21. Okay. So let me go ahead and put some room here for -21. And there you go. That is our range.